So in this video, we are looking at solving simultaneous equations by substitution. Now, in order to do this, we need to think back to something that we spoke about last video when we solved graphically. So if you look at this little picture I've done down the bottom in blue, we remembered that the solution to the simultaneous equations was a point that satisfied both equations. So essentially, because it lay on both of the lines, the x and y values of both equations were exactly the same. Now, hold on to that thought because it's going to be very important when we get into the first example. But I've got the steps here for solving simultaneous equations using the substitution method. We essentially want to make one pronumeral the subject in one of the equations. So we want to get it on its own. Then we want to substitute the expression for this subject, so everything on the other side, into the new equation, into the other equation, I should say. What that's going to do is instead of having these two equations where individually they're impossible to solve because you have two unknowns, which you can't solve, by substituting, it's going to give us an equation with the same pronumeral. So now that we will have the same pronumeral, we can find the value of one pronumeral by just solving the equation. Then we substitute the value into any of the equations to find the value of the second pronumeral. We're going to look at how this works over here. Now, in this first example, we have these two equations, and thinking back to that idea I said before, this y value is going to be the same for both of the equations. So these two are exactly the same. Now, here y is the subject in both. So it doesn't really matter what we do, but what I'm going to do here is that because this negative x is equal to y, and this y is also the same as this one, I'm going to substitute negative x in place for this y over here. So what I'm going to say is I'm going to sub equation 2 into equation 1. And what that's going to give me is everything within one equation. So you're going to see the y is going to disappear. And now I get an equation just with x present. From here, I can subtract 2x from both sides to get it with the other x. I'll get negative 3x here equals to positive 3. And then I want to divide both sides by negative 3 just to get x on its own. So this will give me x equals to negative 1. So this is my x solution, the x value of this particular equation. That's a solution to both equations. Now, since I have this, I can substitute it into either of these ones to find y. Because it's the same point, no matter which one I sub into, I'm going to get the same y. So you can substitute into either, but what I like to usually tell people is to go for the path of least resistance. I can sub this thing into either equation 1 or equation 2. Equation 2 just has less going on, so it's kind of less opportunity for me to make an evaluation or a calculation mistake. So I'm going to go for the path of least resistance, and I'm going to sub x equals negative 1 into equation 2. What that's going to give me is y equals negative 1. And that's going to give me that y equals to positive 1. So this is my solution to the two simultaneous equations. And I can check this by substituting back into both of them. Now, y is 1 here, so I can imagine 1 on this left-hand side. If I sub in negative 1 in for this x, I'll get 2 times minus 1, which is minus 2. Plus 3, which gives me 1. So 1 equals 1. It's a true equation, so it's a solution. Both of these are a solution to this first equation. And the same thing goes for the bottom one. 1, which is this y, equals to minus 1. Minus 1 just gives you 1. So 1 equals 1. This is a solution to the pair of simultaneous equations. In this next one, we are going to let's rub this out. We want to solve this pair of simultaneous equations. And what we notice here is that we again want to make one of the pronumerals the subject, but I notice that I have 3x here and 3x here as well. So these two are exactly the same. So because x is the same, 3x will be the same as 3x. So if I can make one of them the subject, I can substitute it in place for the other one. Now, I'm just gonna rearrange equation 2 because I don't like the 3x being negative. So I'm going to rearrange equation 2. I'm going to move the 3x to the other side by adding it. So I get minus 2y equals 3x plus 8. And I'm gonna subtract 8 from both sides to get 3x on its own. So I can say 3x, I'm just changing the order. I've just written 3x on the left-hand side because I prefer it, equals to minus 2y minus 8. Because remember, I have to subtract 8 from both sides to get rid of it here. So 3x equals minus 2y minus 8. Now, this guy here, because it's an expression, or this is another way that I can say 3x, this I can substitute in for this guy up here because they're the same. Remember, this is the same as 3x. This 3x is the same as this. So I can substitute it in. Now what I'm going to do is I'm going to sub equation 2 into equation 1. So what I'm going to get is I get that instead of writing this 3x now, I'm going to write minus 2y minus 8 plus 5y, because I'm writing the rest of it the same, equals to negative 11. Now I can clean this up. I can say that 3y, positive 3y, minus 8 gives you minus 11. I'll continue up the top here. 3y, because I want to add 8 to both sides to get it to the other side. So 3y is going to give me negative 3. So dividing both sides by 3, I get that y equals to negative 1. So this is my y value here. Now, once I have this, I'm going to substitute it into either equation 1 or equation 2. It really doesn't matter, okay? It's going to give you the same answer. But what I'll do is I'll sub y equals negative 1 into, let's go equation 1. So this is going to be done in order to find x. So I have 3x plus 5 times minus 1, because I'm substituting negative 1 in for y, equals to negative 11. So I get 3x minus 5 equals minus 11. So I just am solving systematically now. So I'm adding 5 to both sides. I get 3x equals to negative 11 plus 5 gives us negative 6. And I divide both sides by 3. I get that x equals to negative 2. So this is my solution to the simultaneous equations. Y equals negative 1 and x equals negative 2. This is how we can solve our simultaneous equations by substitution. Thank you so much for watching, and I'll see you next time.